and welcome once again to this Bonitasoft webinar. Today we are aboard the Bonita Express and we are arriving at stop number 5 to the minds of our processes because we are discovering process mining. Today we have a very special guest. I'm so glad she can join us for this stop. Her name is Noor. Hi, Noor. And let me introduce you, Noor, my colleague Noor, who works, at Bonitasoft, but she's developer advocate for the process analytics project. So if you don't know this project, well, it's perfect because she will explain all that to you today. And well, process mining, she has a lot of experience because she worked for several years during her thesis on this subject. So she is really the good guest to have here today and discover this topic.
Thank you very much, Talia, for this introduction, and it's a pleasure to be with you. My name is Noor. I'm a developer advocate for the process analytics project that you're going to discover today. And as Talia said, I have a background in process mining research, and currently I focus more on the practical aspects from an industrial perspective. So I invite you to embark on the Bonita Express as we explore together the field of process mining and discover the process analytics project. Let's start. So this presentation is divided into 2 parts. In the first part, I will introduce the field of process mining, the problems it solves, the format of the data required, as well as the techniques. I will not go into detail on each technique, as this would require a dedicated webinar or a separate tutorial. Today, our main objective is to give you a global overview of this field and to allow you to better understand its importance and its potential in your organization. At the end of this part, Talia will show you how to extract process mining data from Bonita to be able to analyze it with existing tools. In the second part, I will introduce the process analytics project that's initiated by Bonitasoft, which is an open source project. I will explain the origin of the project and the challenge it specifically addresses. And also at the end of this part, I will show you the project in action through a demo of one of its provided libraries. So let's start with the first part, process mining. We're talking about process mining, so to talk about processes in general, I will start by showing you a map of an airport published by the Japan Airport website to explain to travelers the steps to follow for a departure, what you see in orange, or for an arrival in green. So for a departure, each traveler who enters this airport goes through a series of well-defined steps such as check-in, security, boarding, and finally taking the flight. So these steps are in fact the description of a process. They are carefully planned and orchestrated to ensure an efficient and enjoyable travel experience. But it's not just in airports where processes are omnipresent, whether in industries such as loan application processes, purchasing and delivery processes, or in hospitals like rehabilitation processes, or hospital admission processes. So processes govern our world. They ensure efficiency, they ensure accuracy and order in our activities. But as with anything, there can be inefficiencies, errors, or simply areas that can be improved resulting from unoptimized processes. For example, long waiting times are often a sign of poorly optimized process. Delivery delays are symptoms of processes that need to be refined. Work overload is another obvious sign of inefficient process. You know, in particular, when certain individuals or parts of the system are overloaded while others are underutilized. So these problems highlight the need to optimize our process. And this optimization is not just a matter of improving performance, right? It's a matter of service quality, of user satisfaction, and at the end of business success. So now that we identified the need to optimize processes, let's move on to the question of how. How are we going to improve our process? And the answer is very simple. To optimize, we first need to understand. If we take, for example, the airport processes, questions that we can ask, for example, where are the bottlenecks? Because these are the congestion points that slow down the entire process. Do they occur at specific times? Are there any factors that might explain them? And finally, how can we predict and prevent them? So with a good understanding and analysis of the process, we can not only react to problems, but also prevent them. To answer these questions and move on to factual, evidence-based optimization, we need data. And maybe you know, maybe you don't know, but with every interaction, every transaction, every step of the process, there's data generated and is recorded in your information systems. If you take the example of the airport processes, so at some point in time when a traveler, for example, named here in our example, Sophie, checks in on 23rd of June 2022 at 10:30, there is data recorded in the system of the airport from which we can extract some data like the name of the operation, in this case, the traveler checked in, the time at which this operation or this activity happened, a unique identifier that can uniquely identify this operation. So in this case, it could be the passenger ID. We can have also additional data like the employee who performed the check-in. We could have his or her name, the role, or just an identifier. We can also have additional data like the flight ID, the luggage weight, and so on. Another example, when, for example, the police scans a specific passport on the 1st of July, we can also extract data such as the name of the operation, in this case, a scanned passport, the date. We can have additional data like the passport ID, the flight ID, from which we can extract the unique passenger ID, and we can also have the role or the employee who performed this operation, in this case, just the police. Now, how do we analyze this data and extract valuable insights? That's where the field of process mining comes in. So process mining is a set of data analysis techniques. And this field sits at the intersection of three key areas: business process management, because we're talking about processes, optimization of processes; data science, because we're analyzing process execution data, so data at the end; and visualization, because the analysis results are at the end visualized and presented to the process experts or stakeholders. And according to Prof. Wiel van der Ast, who's considered as the founder of the field, process mining is not just about visualizing how your processes work, but also about anticipating and diagnosing performance and compliance issues. So by using process mining tools, we can extract knowledge from our process execution data, identify bottlenecks, quality or performance issues, and make informed decisions to improve our operations. Now let's go a bit more into details, and let's start by understanding the type and format of data needed for process mining analysis. So if you want to do process mining, the data should have a representation, some representation, and some attributes. Let's take the example of data generated by the execution of a loan application process. So this process has been explained in step 3 of this series of webinars. And today we were looking just at the data perspective. Here we have data generated from this process. For process mining, to be able to conduct process mining, there are 3 mandatory attributes that you should have in your data set. If you don't have one of these attributes, you cannot conduct process mining. The first attribute is what we call a process instance identifier, or a case ID. So this is an attribute that allows us to uniquely identify one execution of the process. In the case of a loan application process, so each time a new request arrives, there is a new execution of the process. And so the loan ID can serve as a case ID. The second mandatory attribute, the name of the activity or the operation or the task that was performed. If you don't have attributes related to this concept, you cannot do process mining. And the third mandatory attribute is a timestamp. So you can have timestamp related to the time at which the activity started, completed, failed. You could have only the timestamp of completed activities. So with only one attribute related to timestamp, you can do process mining. If you have more timestamp related attributes, you can conduct a more rich analysis. Now we can have additional attributes such as the actor, or it could be human, or the resource. It could be a machine that performed the activity, and the data manipulated by an activity. For example, here we have, for example, the loan amount. If you have these additional attributes, we can conduct an in-depth and enriching analysis. Now, if you look at the content of the rows, we can identify, and let me just precise something, that here each row in this data is referred to as an event. In the process mining domain, we refer to this as event, and this is why we talk about event data. So event data is just the process execution data. If you look at the content of these rows, we can identify all the events related to one execution of a process. So here, if we look at this specific loan ID 360, which represents the case ID, we can see the sequence of activities that were executed in this process. So for this process, it started with requesting a loan, then validating the loan request, writing the loan contract, and finally signing the contract. We can look at another ID, which is here the 500, and we can see another process instance. So the sequence of activities executed for a second process instance, and so on. Now let's move on to the process mining techniques, and I believe it's highly relevant to present these techniques through the life cycle of a process mining project. What I'm going to present now in the diagram is taken from the process mining handbook that has been published recently, and that I highly recommend, as it's addressed to the community in general and also to practitioners. So a process mining project, first of all, begins by formulating the right questions. What answers are we seeking, and what KPIs do we want to calculate or monitor? Once these questions are defined, the techniques start with data extraction from information system, as you see here. So if you're utilizing a BPM solution like Bonita, this data is already recorded by the Bonita engine, and Talia will show you shortly how to extract this data. But even without a BPM solution, you can extract this data from systems like ERP systems like SAP, which already have an inherent understanding of a process. And also there's an ongoing research on extracting such data from more diverse systems, like from sensors or unstructured sources like emails, which often contain process-related communication. So now, once we extracted the event data, much like any data science project, you can explore, select, filter, and clean the data. So existing data exploration and pre-processing techniques can be used here, but there are also some specific methods for process-related data. And here I will show you some example. What you see here is a visualization of the data in a compact way, and it's used to illustrate the different execution sequences recorded in the data with their frequencies. For example, to give an example, we see that in the first line, we see that in 30% of the process execution recorded in the data, the process followed this sequence of activities. So it started with requesting a loan, followed by reviewing the loan request, and ended with notify refusal. So these sequences of activities are usually called variants in the process mining, and here we visualize the variants with their frequencies. This is another visualization that track the progression of each case of each process instance and visualize the event timeline. So in this dotted chart, each line corresponds to one case, to one process instance recorded in the data, and each dot corresponds to an event. So you can think of it as a row in your event data. And the dots here are colored based on the activity names. So the purple dots that you see here refer to the activity ER registration. The x-axis illustrates the timeline. So this allows you to observe the trend of case progression and the arrival of events in such visualization. Now, once we explored our data set, we selected, we filtered, we prepared the data set, we can start the analysis. And one of the primary techniques of process mining is called process discovery. This technique automatically generates a process model from the event data. For example, a process model in BPMN. And I would say that this approach is particularly useful if you don't have a BPM solution yet, so you don't have your processes modeled, but you have data and you'd like to put in place a BPM solution. So instead of manually modeling the process, you can automatically discover the process model in BPMN from your data. And here with this animation, I show you that from an event data, we can run an algorithm and discover a BPMN process. So the idea behind these algorithms is to explore the relationship between events that are recorded here in the data to construct a model that is as accurate as possible and that reflects the behavior observed in the data. This model is then presented to business experts and process stakeholders for validation and is adjusted if necessary. So I won't delve into the details of these algorithms, but it's important to understand that these techniques try to balance various quality criteria. We have model accuracy. We want to discover a model that is as accurate as possible. There is simplicity. We don't want to discover models that are overcomplicated so that they cannot be inspected by humans. And there is the representational bias of the chosen language. You know, you have different languages for modeling processes. And for example, if you want to discover a BPMN process model and the language is very rich, you have gateways, events, pools, and all this information. While in the data, you have only activities, the notion of activities. So here you have a complex discovery problem. And just to say that in existing, well, most of existing commercial process mining tools use another representation that's called process map, which is simpler and but it's informal, so you cannot execute a process map. You can just use it for visualization. Now, once we have a process model, whether it's been automatically discovered from the data or previously modeled, we can compare the data against the model using what we call alignment and replay techniques. So this comparison allows us to calculate various metrics to assess the performance and conformance of the process. For example, if a process is modeled just for documentation purposes, conformance checking techniques can verify whether we are deviating from the intended behavior that's documented in the process. We can also check if our process aligns with rules related to our KPIs. Suppose there's a rule stating that the lead time shouldn't exceed a certain threshold. So in that case, conformance checking can spot instances where this rule was violated. We can also compute different performance metrics, which I will show in the following slides. And then the results are presented to business experts for interpretation and validation. We may need to refine the analysis further and drill down into specifics. And based on the results of the analysis, we can then take measures to improve the process. Let me show you some examples of statistics we can compute. For example, we can determine the execution frequency of various activities and directly visualize this information on the process, as you see here in this figure. So for instance, we can observe that the majority of requests were rejected. Here, out of 50 requests, we have 30 that ended in rejection. And we only have 9 that were at the end accepted and credited. We can compute different performance-related metrics, such as the average duration of activities, as you can see in this visualization. And here we can immediately identify that the request validation step the request validation step is the longest in the process, followed by the additional review step. So to speed up the processing of requests, it will be necessary to identify the cause of these bottlenecks. Then to refine the analysis to dig deeper, we could compare the performance of executions that, for example, ended in acceptance with those ended in refusal. And this type of analysis is known as comparative analysis in process mining, where we compare two data sets. For instance, we can split the data into last year's request versus this year's, or requests coming in during the summer versus those coming in during the rest of the year, and perform a comparative analysis. So in our example here, we are comparing the accepted versus the rejected loans. We can directly observe what you see here on the left-hand side is the average duration for the accepted loans, and on the right-hand side for the rejected loans. So we can directly here spot that the bottlenecks that were identified from the previous analysis and the previous slide comes from the accepted loans, which take an average 25 hours. Here's another type of visualization in the form of a matrix where we visualize the average waiting time between activities. For example, we can observe that the waiting time between validate loan request and writing the loan contract, which is an average 10 hours. So depending on our KPIs, it could be a significant waiting time. So it's necessary to closely inspect the causes of this wait. With this visualization, we see aggregate at an aggregate level, so average waiting time. We can have a more detailed analysis of waiting time, and here this is called the performance spectrum, which allows to visualize the waiting time for all instances in the data. So each bar that you see in this visualization represents a waiting time between two instances, and the horizontal axis indicate time. So the more a bar is inclined, the longer the waiting time is. And you have the color coding so that we can distinguish between negligible waiting times in blue and most significant ones in red. And in this example, we can observe that the waiting times were significant from July to September. So this is usually the holiday period, while they were very short in June. And finally, in this step, we can animate our data on the process in order to observe the path taken and their speed. So in this figure, we have a simplified process. By the way, this is called a process map. It only shows the activities and the relations between them. We don't have gateways, we don't have events, we don't have pools. And each token represents an instance of a process, one instance of a process, with the color of the token is configured according to the role that executed a specific activity. And here each token travels the path of activities as it is recorded in the data, and the speed of the token is proportional to the duration calculated from the data. So all previous analyses that I've showed you are done in an offline setting. However, there are online techniques such as predicting and recommending actions in real time during the execution of a process instance. And here, typically, machine learning algorithms are employed for these predictive and prescriptive tasks. Let me show you some examples of online or real-time monitoring and predictions in process mining. For instance, when a new request comes in, it's important to be able to anticipate how it will conclude. So will the request be accepted or rejected? If we look at this figure, we can see that the activity request, a loan activity, has just been executed. And then we have a prediction system that could inform us that there is a probability of 0.8 that the request will be accepted and 0.2 that it will be denied. You might also want to know about the next activities that will be executed. So this information, for example, would allow us to notify the relevant parties in advance to ensure their availability and accelerate the process. And here again, we see this activity that's executed, and then the prediction system predicts that this is the most probable path that will be taken by the instance. So this instance will require an additional review step. We could also ask about the remaining time before this request is fully processed and finalized. So understanding the probable execution delay can help us manage customer expectations and optimize our resources. And again, in this visualization, the prediction system predicts that for this path, it will take probably 6 days to complete. I've now reached the end of the process mining part. What I presented is just what we call the tip of the iceberg. There are a lot of other subjects and current trends in the domain. For example, with organizational mining, we can analyze the social network of people, roles, systems involved in the execution of the process. Streaming process mining is a subfield on its own and allows to perform online process mining with streaming data. Object-centric process mining is considered to be the field's future. It relaxes assumptions about the data format, and on a higher level, it aims to provide a holistic approach for analyzing different processes interacting with each other at a more global level. We have process simulation and constructing digital twins, so being able to simulate different scenarios and optimize the process. Responsible process mining is another trending topic. The question is how to protect data, ensure privacy, and conduct analysis in a responsible way by adding transparency and explainability. Finally, the topic of unstructured processes and data in general. For example, how to enrich our data by extracting process-related information from unstructured sources like emails and documents. That's all for this first part. Now we go to showing you the data extraction from Bonita. And Talia, you take the lead on this?
No, you can continue. Yes, if you could show just the slides. Yes, it's perfect for me. I will read a question that arrived. I think we are going to answer it in the next part, but I will read it now. It's from Madan, and he's saying, is there any process mining inbuilt tool available in Bonitasoft platform to find out the bottlenecks in the process? So I can say that no, we don't have an inbuilt tool for process, specifically for analyzing the bottlenecks in the process. However, as you will see in the next section, we will explain what the process analytics projects is doing, even if we have already seen a little bit in the example shown by Noor. So now let's take a look at how to extract data from Bonita. What you're seeing here is a model, a process. So we first choose the process, then we get the instances that are finished, and then we treat them to create a CSV. So it has the same format that Noor explained to us. For this example, I'm using then a form to show you which APIs to call, because this is what we should be doing, calling APIs and then forgetting this information. So I'm opening the UI designer. You can see that there's a variable called archive cases, which is of type external API, because I will be calling the archive case API available on Bonita. And I will be giving as a parameter the process definition ID, which comes from the selected process ID. Okay, let me tell you where this selected process ID comes from. So again, there is another variable called available processes, which in fact gets all the process, calls the process API, and then gets all the list of processes available in there. I will be using then the table widget to show the results of this call. and show the available processes, and the line that is being selected, then it will be saved on selected process variable. So as I was showing just before, let's go back to this variable called archive cases. So that I'm calling the API called archive case, and then there you can see that my variable called selected process, I'm calling specifically the ID, because yes, it's a JSON, and the ID is saved on the .id. The archive task as well, I can get them by calling the archive task API, and again, giving the selected process ID as the process ID parameter. And well, all this information, I got it from the website API documentation.bonitasoft.com. I looked for archived. So archive means all the instances, all the information, yes, related to instances that are already finished and that are no longer yet alive. So they are archived. And so that's how we are getting, so the archive task, the archive cases, the archive, yes, activities, in order to get, the data from past instances. So I will launch this process so we can see the results. So yes, there you can see the whole list of processes that are available. I will be picking up loan request pool. And then we can see that there are 2 archive instances of this process in there, and then I'm getting the archive tasks. So it really looks kind of what Noor showed us. And I'm exporting this data to CSV. So yeah, we'll show you what this CSV looks like. But yeah, it's kind of, do you remember we have some parameters that were mandatory for doing process mining? So there they are, the process instance ID, the activity name, and the complete time. Those are the 3 mandatory, and all some additional ones as well. That's it. So for the Bonita part, and now, yes, now that you have this data, then you can use one of the techniques, for example, that Noor explained, and then visualize them, for example, and then arrive to some recommendations, conclusions. It's up to you, Noor. Let's go back to the, let's continue to the second part.
Thank you, Talia. I think, do you see my screen now?
Yes, I see it correctly.
Perfect. Yeah, I have many popped up windows. Yeah, so let's move on to the second part, where I'm going to talk about the process analytics project by Bonitasoft. I will start by explaining the challenge that we are addressing in this project. So, and the challenge is actually a visualization challenge in process mining. But what kind of visualization challenge? In fact, this project is addressed for developers. And as a developer of process mining-based applications, you have requirements regarding the visualization of data analysis results. So to clearly present results to stakeholders, you need suitable visualization, because your project has its own requirements and necessitate appropriate customization. Unfortunately, existing or most current process mining tools offer predefined visualizations, and these are primarily based on process maps rather than the BPMN standard. So yeah, this restricts the developer's ability to customize visualization and limit the ability to optimize the process analysis part. So it's crucial to have access to more flexible and customizable visualization libraries for process mining. And by analyzing the market needs, Bonitasoft noticed that these visualization needs were not limited to its exclusive use case. These needs are shared across different markets, such as BPM, process mining, BI, RPA, and others. However, there was no common technology or ongoing initiative to fill this gap. And so the process analytics project was born at Bonitasoft with the aim of developing visualization libraries capable of addressing the specific needs of developers. The project aims to create a customizable open source ecosystem in order to offer easy integration into existing tools. As I said, it's designed for developers. We provide libraries for developers to enable them to create applications for visualizing business process execution data. Now, why open source? There are several reasons for which we decided to make the process analytics an open source solution. First, open source is at the heart of Bonitasoft DNA. We want to create a dynamic community of developers and business experts who share our passion for business process data visualization. And open source also allows us to facilitate the adoption of our solution by enabling everyone to customize it according to their specific needs. And also, here it's very important that it will allow us to collaborate with other editors and market players to offer an even more robust and comprehensive solution. The project is developed using a variety of technologies. We mainly use TypeScript and JavaScript for the data visualization libraries. We also offer the libraries in the visualization libraries in R for data scientists and researchers in general. We have libraries developed in Java for the server components, and last, BPMN is the standard format used by our libraries for the representation of business process. You can integrate these libraries into Bonita. You can use them with web development frameworks like Angular to create custom visualizations applications. You can also integrate them with server-side languages like Python for more advanced data analysis, and of course, many more. If you want to learn more about the project, I invite you to visit the website where you'll find detailed information about the libraries, their documentation, examples and tutorials to help you get started, and also you can sign up for the monthly newsletter. Now I will go directly to the demo part where I'm going to show you a demo of the visualization library that's called BPMN Visualization of the Process Analytics Project. So the demo is based on a purchase to payment process of a company operating in the coatings and paints industry. The data related to this process are real, and they were shared during a challenge called BPI that's organized annually by the process mining community. So this data comes from BPI 2018. What I'm going to show you in the demo is the front-end part of, and specifically the visualization part of a simulated monitoring system. So in this, we simulated the monitoring system, and in this front-end part, I'm going to show you what you can do with BPMN visualization to visualize the results of the backend analysis, how you can interact with the process, and I'm going to show you some examples of taking actions. And all of this is with the goal of showing you an example of what you can develop with the library. And I want to clarify that this demo is not a tool provided by the Process Analytics project, but rather a small application that we've developed using the BPMN visualization library. Let's go to, let me just reopen the demo. So here I'm on the GitHub page of Process Analytics. We have a demo that we can show directly online. And what you see here, first is the BPMN process that's modeled for this data that's shared during BPI challenge. So this process has been modeled, designed by the participants to this challenge, mainly the first part. You don't have to understand all the details, but here in this first pool is the process for requesting a new order item until the payment is done and the invoice is generated and cleaned at the end. The second pool is for a process for contacting a supplier via email. So what the BPMN visualization library allows to do is to render this BPMN. You know, BPMN processes are usually stored in XML files with the extension .bpmn. If you provide this file to the library, it can render it for you. And you can see you have the gateway, the pools, the human activities with this woman pictogram, service activities, and so on. The second thing that the library allows you to do is to interact with the elements, with the BPMN elements. And here you can see a sub-process. So we defined an interaction on this activity. Whenever we click, we visualize the details of this sub-process. So this is an example of interaction. Now, the first use case that I'm going to show is about process monitoring, and offline monitoring. And what you see here is that in the backend part, we computed the most frequent variant. If you remember the visualization about variant, so the most frequent sequence of activities, we computed it. And here in the front-end part, with BPMN visualization, we changed the style of elements to visualize this sequence. And you can see this animation where we show the order in which the activities have been executed as recorded in the data. Now you can, depending on your application, on your requirements, maybe you want to visualize the most performant variant, the less performant variant, the less frequent variant. All depends on the applications and the requirements of the project. With the second use case, this is an online monitoring, and here we are in a scenario where a new instance or an instance of the process is executing. And with BPMN visualization, what we did is that we blurred part of the process to indicate to the administrator of this application that these activities have been executed and are completed. And here we highlighted this activity because in our monitoring system in the backend, the system identified that this activity has problems, is running late. So to attract the attention of the administrator, we highlighted it in this way. And now another example of interaction, when we hover over the activity, we also show information that's communicated from the backend. So here the monitoring system is saying that the task is running late and is proposing some actions. The first one is to reassign the actor because apparently the actor is unavailable. We want to take action. Here we see the sub-process inside the activity. And again, we blurred the parts that have been completed, and the problem is at the level of this activity for awaiting approval. Again, when we hover over the activity, we can see that the actor is not available and the system recommends other possible actors. So here we see that Maribel has executed the activity document completed 12 times in the past. So with BPMN visualization, we add these overlays. We update the style of the activities. And I can see that May has executed the activity awaiting approval in the past, so I'm going to assign the activity to her. Now, there was another action recommended by the system, which is to notify the supplier about this delay. So if I take action, you will see here that this sub-process for sending an email to the supplier is launched, is executed. And again, we can see the parts that have been completed. And here we are at the activity review and adapt email. And here we simulated a call for ChatGPT that will recommend an email for us. So we can generate the email and send it to the supplier, or we can validate it and send it to the supplier. We can choose to change the prompt and regenerate another email. And here we can see the path that's taken by the process. So if I'm okay with the email, I can validate it. It will be sent, and the process terminates. So through this demo, through this small application, I wanted to show you some of the features, front-end features, visualization features that you can implement with BPMN visualization. Let's go back to the slides. Here are some additional resources. I just want to. So here are some additional resources for open source libraries in process mining, like BPAR, which is in an R language. You have PM4Py, which is in Python. You have open source tools like PROM, but PROM is more a research-oriented tool. And for process mining visualization, you have the Process Analytics project, and more specifically, BPMN visualization. And yeah, all BPMN-based visualizations that you saw in these slides are generated using BPMN visualization. And for the analysis part, I used BPAR. To wrap up, so process mining complements BPM by opening up a new domain of fact-based process optimization, because it relies on concrete data, not only assumptions. I also presented the visualization challenge, because process mining tools provide predefined visualization that cannot be customized if you're developing process mining-based applications, and that the Process Analytics project addresses this challenge, this limitation, by providing libraries for developers, visualization libraries for developers. And last, thank you so much. And let's see, Talia, if you have questions.
Yes, so I think just, yeah, Madan, if you still have this question, I hope we have answered your question about the tool to find out the bottlenecks. So it would be using, what would you recommend, or using maybe today BPAR, for example, as you did on your examples. Once you get the data from your archived cases, you can use this tool, and then you could find these bottlenecks and then visualize them using BPMN visualization. Do you think maybe that's a good summary for Madan, who was asking, who was interested in how to find out bottlenecks on the process?
Yeah, sorry, Talia, I didn't hear you well. Can you please repeat the question? Because I was looking at searching for the question, so I didn't pay attention for the details.
Yes, okay, yes. I was saying that Madan was previously saying how to find bottlenecks on the processes. So I would say the summary is, take a look at the data of your process, then use one of the process mining tools, such as BPAR that you show on a previous example, then use a tool for visualizing this on your process, like BPMN visualization from Process Analytics. And then, well, you can have some conclusions and some, for bottlenecks, you can easily find those on, like you did on one of the examples shown at the beginning. It's like that. Is that like the good summary?
Yeah, exactly. It's perfect summary. And I want to add that in Process Analytics, in the project, we developed a demo, let's say an integration demo with the PM4Py, the Python process mining library. So in the backend, we had PM4Py for the analysis part, and in the front end, we had BPMN visualization for the visualization part. But yeah, this is not a tool. This is like a demo. We chose like 2 techniques to showcase them, and that you can, by the way, find on GitHub, on our GitHub repository, process-analytics. We have it with, I think, PM4Py. BPMN visualization PM4Py. This is just an example of developing applications with backend and frontend. But if you want to visualize, to compute bottlenecks, I would say, you have to use some of the open source libraries that I presented to perform this, and then check whether the visualization of these libraries fit your needs, correspond to your needs. If not, if you want really to use BPMN, because these libraries don't provide the visualization on BPMN, if you'd like to use BPMN, you can then develop and use BPMN visualization to choose the visualization that you'd like to present to users.
Great. We have another question. This is from Norbert. Is this now mainly process visualization or mining, like conformance checks and mining algorithms like alpha algorithm? And so the second question is for the conformance checks. Is there something in the library? I would say in the process analytics project, is there something for conformance checks?
Yeah, so to clarify again that the currently the project is developing only visualization libraries. So you can think of it as the front end part. We don't have analytics techniques or analytics algorithms. So we don't provide, as part of the process analytics today, we don't provide process discovery or conformance checking techniques. We allow to visualize the results of these techniques using BPMN visualization. And by the way, for the conformance checking part, with the demo with PM4Py, we showed how we compute conformance checking in the backend and then visualize the results in the front end with BPMN visualization. So process analytics project currently doesn't provide analytics backend libraries. Now, for the first part of the question, is this now mainly process visualization or mining? So this for what exactly?
I think maybe it was, if I understand well, it was for the process analytics. Was there something specifically for doing the process mining? But as you said, this is it's mainly concentrated for now on visualization, on libraries on visualization.
Exactly, yeah.
Okay, I can add as well that on the subscription edition of Bonita, we have integrated the BPMN visualization library, so you can monitor your cases in real time. So yes, that's also very helpful, and we are still working on how to make it easier to continue monitoring this. So, but yes, this will be more enriched monitoring will be coming on next versions. But for now, yes, you can already monitor your cases in real time with subscription edition. Another question we have, so about these other visualization variants from the beginning of the presentation, is that part of the library?
No, these the visualization that are not based on BPMN, I did them with Bupar. So currently we have all the visualizations that are related to BPMN. So how to visualize results on BPMN, this is part of the library. All other visualization that you saw on the slide, yeah, as I said, is from Bupar library.
Can you maybe just show one of the slides where we are using this library so it's clear for everyone which one is using the the personal project?
Yeah, so let me clarify. So these dotted charts, variants here, this is from Bupar. This is from BPMN visualization. Yeah, everything that's based on here on BPMN, it's from BPMN visualization. And again, I chose to generate this visualization. You may have other requirements and you may need to use other coloring scheme or other like overlays. So you choose what you want and how do you want to visualize. And maybe I can show you something that if you go on the website process-analytics.dev, you have here the demo section in which you can see many demos that we prepared with BPMN visualization. You have also here the getting started tutorial that describes step by step how to reproduce this visualization. And more interesting is that this part where we have some pre-configured environments like Code Sandbox, that you can use to play with the library. So here in this environment, we prepared a very simple example to show the different functionalities of the library, the different APIs that you can use. So you can directly start working with the library without any local configuration or setting by using this pre-configured environment. And maybe by looking at this example, you can understand, you may have a clearer understanding of what's possible with BPM and visualization and what's not possible today.
Great, thank you, Noor. So I would say also, if you're not still using Bonita, for example, so why not fetch your data from another system if you're using ERP, discover your process, model it on BPMN, start using Bonita, why not? Then run some cases, fetch your data, study it, visualize it with process analytics libraries, and then optimize them. Yeah, don't forget what we are trying to achieve, better and better processes.
We have a last question, Talia, before the end of this session. Yeah.
Yes, it comes from Uriel, and he's asking from which version of the Bonita subscription you can monitor cases in real time. It's 2022.2, so it's our not the latest one. The latest one is 2023.1, and so this added value, this value was added on 2022.2. So, but yeah, start using 2023.1, and you will be able to monitor your cases. And also, yes, another question from Uriel, sorry. Is there any tutorial or demo about how to use those tools to monitor in real time? Do you mean about on Bonita? Would you say? I think there is not really something specifically like how to use it, but we showcased that part when we presented the 2022.2 version. So it really looks like what Noor presented. Yes, you can see your diagram and then just the instances that are waiting for your for being achieved, and it's a global view of all your instances. I will put the link to this if you wish, to this part of the reference where we showcased this part of Bonita subscription when it was introduced, this value. Okay, well, is there any other question? I also saw some very nice comments, so thanks a lot. Fortunato was saying very nice for what everything you showed and all the libraries you were showing, Noor. Yeah, some people that have to leave, but well, we will have the replay, so don't hesitate. You will receive this next week on your email if you subscribe, and if not, you can see it on bonitasoft.com /events, /video, sorry, for the replays, and you can take a look at all the past webinars as well. Okay, is there any, maybe we can have 1 more minute for one more, but if not, then yes, we can stop in here. Maybe Noor, also the final word on your side.
Yeah, thank you very much for attending today. And yeah, my final words would be to, if you didn't start yet with the process mining domain, start with the tools. For the process analytics project, just to say that this is an open source project with Apache license, so you can use it in commercial solutions. It's a project where the roadmap is defined by the community, so we welcome all contributions. If just you use it, you give us feedback. If you're more like developer and contributor of open source projects, so don't hesitate to reach to us. And yeah, if you have any question related to process mining in the future, don't hesitate to contact and reach us. Thank you again.
Great, and thank you, Noor. I love when I talk to you because I learn so much, so many things. Really, I think process mining is such an interesting area and field. So I hope, as myself, you enjoyed this webinar, and we'll see you next month with some new content. Well, yeah, thank you again for your time, and see you soon.
See you.
Bye-bye.
Bye.